Hello, you're welcome to Master Tima class. And in this live class, we want to look at some interesting question on sets. And when we talk about sets in mathematics can be defined as the collection of well-defined objects. So when we talk about set, we are talking about collection of well-defined objects. That is a group of objects that have similar properties. That is, they are well defined. And we use some notation in sets. For instance, capital letter is usually used to represent the set. We have sets A. Let set A be set of even number between 1 and 10. Between 1 and 10. Actually, this here is a way of describing set, which is known as set builder notation. Okay, this is called the describe. Okay, so here we are talking about sets. All right, and we define sets as a collection of well-defined objects. And we'll look at the example here just to illustrate what is meant by well-defined. We discover that this set A is set of even numbers between 1 and 10. Okay, so when we list it out, we have 2, 4, 6, 8, 10. So these are even numbers. That is well defined, well described. So that's when we can refer to it as sets. And we make use of what is called curly bracket. So it's different from ordinary bracket. That's the bracket allowed to be used whenever we are working with sets. Okay. And also we separate each of these numbers with comma. So we put comma in between. And each of these number here now is referred to as elements. So when we talk about sets, there's some terminologies we use. Sometimes it is referred to as member. So instead of element, also we can call it member. Now, when we are working with set, there are some things that we should note as well. That is, there are some operation on set, especially when we're talking about set theory. We have some operation that we perform from set theory, and those operations we list it now. Now, I just explain the meaning briefly so that we can solve some interesting questions. Then, from here, we have the first operation we should be looking at. We have intersection. Intersection. And there is a symbol for intersection. Understand? It looks like N, but it's not N. So it's facing down like this. So just like an N. So intersection. And intersection means what is common between two or more sets. That is the element common to two or more sets. All right. So when you list out what is common, for instance, now, e.g., looking at the set we listed now, you can say what is A intersection B, and from here we write the set, that is the element of A intersection B out, and that here is what is common to both A and B. When we look at it here now, we have 2 is here, 2 is here, so 2 is common. So 4 is not here, 6 is not here. Also, That's the only thing common now. So 2 is the only thing common between the even and the prime number from 1 to 10. So that is it. And this is called a singleton set. It's just having one element. All right. Okay. Now, what if there is nothing common? When nothing is common, it is called empty set. And there's a symbol for empty sets in mathematics. Also, these are what is when there is no element inside the set. We can use two, notation for it. You might write a curly bracket without anything inside, or we can write this, that this write 0 and cross it. So this is meaning same thing as empty set. But the second one here is more preferable because mistakenly, if anybody should come here and put a dot here, so this one is now a set of punctuations in English. That is a set of punctuation now that is having full stop alone. So it is advisable to use this other one as empty set. Okay, that's not where we are going now. I believe you are enjoying this class. This is Master Team Math class, a channel meant for mathematics alone. So why not be part of us so that we can solve math together daily and we enjoy it too. So just click on the sub and you can as well join our membership package. Thank you for doing that. And don't forget to share and like this video. All right. So we have the number 1 here as intersection. And I believe we got that. So this is symbol for intersection. And it means what is common to two or more sets. Example of what is A. Like when we have A intersection B, what is common to A and B? And it's just an element here. That is just one member. All right. Now let's look at the next operation here. And that is union. Union. Union is represented with like a letter U, but it's not letter U, okay? Just like a letter U. So union means combination. Combination of two or more sets without repetition. So combination without repetition, bringing two sets together or more sets without repetition now. So that's union. We combine the two sets. That's union. Union of two sets. All right. Now, when you look at this, from what we have, we can still use this one as A union B. And it means we combine. We combine these two sets now without repeating one twice. So it will be 2, 3, 4, 5, 6, 7, 8, 10. So we have combined these two sets now. That is A union B. So these are the two major operations we have. And we still have one operation which is referred to as complement. And complement means the element not in that set, but we can find in the universe set. For instance, let's write the universe set for these two sets here. And the word universal set, universal, when you hear the word universal set, it means the set that is containing all the elements under all the sets under consideration. So it's a broader set that contain these two sets. For instance, the universal set, we denote it as this symbol, or sometimes we can use this symbol. So when we say this universal set here, we are talking about from 1 to 10. When we list it at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have this as universal set. Now, whenever we talk about complement, for instance, complement here, complement of a set, and this is usually represented with a stroke on top of the letter. So if I want to write a complement, I will say a complement. And a complement means universal set minus a. That is the element that is not in A, but it is in the universal set. Now, other word, take away set A from the universal set. Whatever remain is the A complement. So now we can write A complement out from this particular example up here now. When I write A complement out, it implies A complement from the example we are looking at. We have to be 1, 3, 5, 7, 9. So these are not inside A, but are in the universal set. So when we write that, we have 1, 3, 5, 7, 9. So these are not inside set A, but are in this set, which is the universal set. So it is called A complement. So it's one of the operations we need in set theory. So I believe we have been able to learn something so far. Now let's continue. Stay tuned. Don't be in a haste. You will surely enjoy this class. So we are going to be looking at some interesting questions. But yet, I want to talk about the use of Venn diagram to represent some of this operation. Okay? The use of Venn diagram. Use of Venn diagram. Venn diagram. And when you talk about Venn diagram, we have this diagram. It's describing sets like the way we have it. Let me list out what we have earlier. I have the universe set as from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I have set A, which is set of even number as 2, 4, 6, 8, 10. And I have set B, which is set of number as 2, 3, 5, 7. Okay? Now, the same way we can use Venn diagram to describe these sets. That is, me looking at that diagram, be able to say, oh, this is what this is talking about. For instance, we are having two sets here, which are subsets of this universe set. Now, when we talk about Venn diagram, now Venn diagram will contain this bigger one as the universe set. Okay? And then the universe set here is having all these elements. Then we have two sets, which means, let me take it slowly a bit, which means that this box written here now, this box drawn rather, we have all these numbers inside. Now this is how I want to share those numbers. Please follow patiently so that you find it very interesting. Now we have two sets. Now I want to use two circles to represent it. But first, before we draw it, take a look at it. And theoretically done, we have something common to both A and B, which is intersection. I hope I'm not too fast. I hope I can get some feedback, stuff like that. God bless you. Now, you see, A and B have something common to them. it implies that when we draw these two circles, they will overlap, right? I mean, they will intersect. We have a circle here representing a circle here representing B, and they are both entering each other. Why? It's because something is common to them. They have one element in common, that's 2, and that 2 should be put here. All right, I believe that's taken. Now, when you take away 2 from here already, what is left is 4, 6, 8, 10. I can write it here. 4, 6, 8, 10. When you take away 2 from B, what is left is 3, 5, 7. I can write it as 3, 5, 7. It means I've written everything inside B already, which is 2, 3, 5, 7. But 2 is common to both A and B. I believe somebody got that. Now, let's look at this. The numbers we have for A and B now, is that all for what we have in the universal set? No, right? We still have some numbers that appear here but are not written inside there. Okay, the first one is 1. So those one will be written inside the box, but will not be inside the circle. I believe somebody is guessing that. So we have 1. We have 1. Okay. The next is what? 9. It should be 10, right? 9. When we count it, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now this 1 and 9, they are not found in both A and B, but are still in the universal set. Now, this region has meaning. It has meaning. So now let's give them name now. This, let me use the red ink now. So this region is A intersection B. That's elements in both A and B. Okay. We just have to understand. This one is element in A but not in B. That's A intersection B complement. B complement means not in B, right? Elements in A but not in B. And this one means A complement intersection B. Element not in A but is in B. Okay. Now this one means element not in A and not in B. So now understanding of this will help us to interpret and solve any problem given to us on that set, even using Venn diagram. So I believe you are enjoying this. All right. Now we still have for 3 set problem when it's having, when we are dealing with 3 sets. 3 sets. For instance, let's add set C now. Let's add set C and use it to describe that of 3 sets. If I have set C here and I call a set of odd numbers will be 1, 3, 5, 7, 9. Odd numbers are this from this particular, that is number that can be divisible by 2. That's simply odd number. Odd number, right? Now it means we have 3 sets now. So we still have the universe set as this box here, and now it's now 3 sets, meaning we have 3 circles. But first, okay, are there is there something common to all the 3 sets? Which I don't think so here. So I might not want to use this because there is nothing common to all the 3. So pardon me, I would like to put 2 here. I just want to use as an example. So it's no more a set of odd number again. So I've described another set entirely. All right. Now let's draw set A, B, and C. has something common to all the three sets, and that is where everything intersects here, which is 2. Then I label this as A, this as B, and this as C. And now let's take it one after the other, because now we have 3 circles, right? So you have to be careful when solving it. You have to take care of the space that have 2, sets first. Like for instance, this region now is containing A and B. Now, when you look at this circle, you have to be looking at it very well. The circle for A and the circle for B is having this endpoint from here to here. When you look at it very well, this circle for A, circle for B. Now, it means that's A intersection B. What is common to both A and B? Now, what is common to both A and B here is 2. Nothing more. It means that there is nothing here again. There is nothing here again. So we have put that to here. Now, this side as well is B and C. From here to here, B and C. What is common to B and C? We have 2. We have written that here. And we have 3. That will be written here. We have 5. We have 7. So we have 2, 3, 5, 7. And 2 is common to the 3 of them. So which implies that 3, 5, 7 is only for B and C. See, that aspect is very interesting. The word only separated 3, 5, 7 from these 2. Though, B and C has 2 as well. But the one that is common to them only is 3, 5, 7. That is why it's not with A. Okay? It must not enter the circle for A because it's peculiar to only B and C. Okay? So this region now is for B and C only. Likewise, this region is for A and B only. And A and B only does not exist. Okay? Now, for A and C now, A and C only. A and C only. It has no element as well because only 2 that is common. So that is that. Right? I hope we could have more bigger example, but we are going there, right? Just to like show us, something here. So now when we write the element in here now, that is left. So this will be 4. This will be 6, 8, 10. And B only left now. B only left with nothing because we have already exhausted what is inside B. So nothing is here. So C only left now. We only have 2, 3, 5, 7. We are going to be having 1 and 9. So that means you have exhausted it. So this region has no element, empty set, empty set, empty, empty. All right. Now, okay. I believe we are getting something here. So let's look at some practical example to demonstrate what we have been doing so far. And these are some interesting example. So do it to give a thumbs up and also share this video so as to reach some audience as well. God bless you for doing that. I appreciate you for connecting, right? Now, we want to look at some practical question now. Okay. Applying the Venn diagram and some principle we have learned from this topic. Okay. So, the first question here we are looking at says, in a class of 40 students, so let me quickly write the question. Sorry, so that we can follow properly. So question 1 says, in a class of 40 students, 40 students. 25 like mathematics. 25 like mathematics. 20 like physics. 20 like physics. And 10 like both subjects. Both subjects. How many students like one? Now I want to answer this question. How many students like one? Only mathematics. So before you even finish writing the question, I believe somebody that understood this as is solving it. One, only mathematics. Two, only physics. Only physics. Three, neither mathematics nor physics. Neither mathematics nor physics. Now, this question is better solved using Venn diagram. So when we apply Venn diagram to this question, we enjoy solving it. And the understanding we are using here is that we know that when we have Venn diagram, we have something like the box here serving as a universal set. That is the totality of this set. And that is given to be 40 because they said in a class of 40 students. So the total number of students here we are dealing with should be 40. Now, 25 like mathematics, 20 like physics. It implies we have just two things we are dealing with, which implies we have two set problem. So it's just two sets we have here. We have just two sets problem. And if the circle will enter each other, we are going to know from the question. Is either we are finding what is common to them or what is common to them has been given. So if either of the two appear, it means we are drawing those two circles, it will enter each other. And when you look at this, 10 like both subjects. It means something is common to the two. So which means we are going to make the two circles overlap. So this is the first circle, this is the second circle. And this first circle now, we can use the first letter of the parameter given, mathematics here. We can use M. And M now, how many students? 25. Please and please, don't write the 25 inside here. It has a reason why. So we are not advised to write it inside. Just indicate it at the top. Now, physics as well. This is physics. And 20 like physics. Write 20 up here. Now, 10 like both subjects. Where the two intersect, put 10. You see the reason why now. Now that you have put 10 here, we can get what is here by saying that everything here should be 25. Then take away 10 from 25. Okay, this will now be 25 minus 10, which is of course 15. So mathematics only, we have answered the question. Mathematics only now is this place, which is 15. So which means question 1 is 15 students solved. I believe somebody is getting physics only for me already. So physics only now will be now 20 minus 10. Because everything here is 20 and we have 10 here common to both math and physics. So when you subtract now, this will be 10. So which means physics only now is 10 students. Now, to get the student that like neither mathematics nor physics now, it means none of this circle is included. It will be outside the circle. So you can put it, you can represent that with a letter. Let's call it letter X here. Letter X. We are finding letter X since it will be outside. Let's call it letter X. And how do we get that? Very easy. Everything inside this box should add up to 40. And before we have 15, 10, 10 plus X should be equal to what? 40. So which means that here we cannot say that X plus 15 plus 10 plus 10, 10 plus 10, 20, 20 plus 15, 35. That's plus 35 equals to 40. And easily we can solve this. Just take 35 here and get your X. It means that number 3, X is now equals to 5. That's 5 students. So 5 students like neither of the two subjects. So that's the first question we want to look at. And I believe you enjoy it. It's an interesting, question. Whenever you see this kind of interesting application of mathematics, it makes you to enjoy solving mathematics. Now, we want to look at another one. And this one is for the 3 set problem. It's also an application of this. So if you have any question, don't hesitate to put it in the comments. And we appreciate you for connecting to us here at Master Team Class. Now, just some minute, please. Be right back. Thank you. Yeah, thank you for staying tuned. Let's look at the second question here, which is also on the application of sets. We're looking at the 3 sets problem now. Okay. This question we have in a survey of 100 students. Question B now. In a survey of 100 students, we have the following: 60 likes football. Okay. 50 likes or like basketball. Basketball. 40 like tennis. 40 like tennis. So that's three sports we are talking about. Then the statement continues. I say 30 like both football and basketball. 30 like both football and basketball. Then also 25 like both football and tennis. 25 like both football and tennis. 20 like both basketball and tennis. 20 like both basketball and tennis. Then 10 like all three sports. 10 like all the three sports. That's the question. Now, that's the parameter given. The question now says how many students? How many students like none of the sports? So it is clear what you are finding. And when we quickly solve this, we also use Venn diagram. That is, we draw this diagram, which is the universe set that contain the elements under consideration. So we have that box drawn. I'll make it a little bit bigger than this. So we have this box drawn here. It contains everything we are talking about. And okay, this universe set is 100 because it is given that the survey of 100 students, the entire thing we are talking about contains 100 students. Now we have football, we have basketball, we have tennis. Okay, so three sets. We are dealing with three sets problem, and we want to draw three circles now representing each of these sets. And first thing we are going to look for in the question is that is there something common to the three sets, or are they asking us to find what is common to them? So if these two things, any of these two things common, it means these three circles must meet, must intersect at a point. So, and like luckily or interestingly, we have something common. They said 10 like all three spots. So now we are drawing three circles now intersecting. So we have the first intersecting with the second, and the third also intersecting with the two. That is, the three circle intersect here. And we can make use of the first letter, and where they intersect here, we can directly put what is given there. That's 10. No waste of time. And here now, we can use the first letter of the game or the sport. Here is football. You can write football, F. How many like it? 60. Don't come inside and write 60. Write it outside first. It's very important. And the second one, basketball. How many like basketball? 50. Write it here. Don't write it inside. Also, the next sport is tennis. This circle is for tennis. Write tennis 40. Don't write it inside. Then you can now calculate those areas that are not yet having anything. Okay. Now the question move on and say 30 like both football and basketball. Now you have to be very, careful and understand this statement. The word 30 like both football and basketball is very clear. And it is different from 30 like both football and basketball only. So this word only is not there. Some question we put only here. And once they put only here, it means that you are no more having the third game the part. But this one is still having a third game part. It implies that 30 like both football and basketball. But those 30, some of them still like tennis. Do you get it now? And you will see it clear now. Like both football and basketball. Where is football and basketball intersecting? That's both. Intersection. Football here, basketball here. They intersect from here to here. It means that this region from this place to this place is for football and basketball. Okay? And 10 is already liking tennis. Okay. And everything here should be 30. It means football and basketball alone now will now remain 30 minus 10, which is 20. That is, everything here should be 30. 20 plus 10, 30. How do we get it? Take 10 away from 30. That gives us 20. I believe somebody is there. And it means that this 20 now is for football and basketball only. Football and basketball only. Okay? Now, same thing, when we interpret further, okay? The next statement says 25 like both football and tennis. The same thing we've done. But this time around is football and tennis. And football and tennis covers, football and tennis. This is football, this is tennis. So it's covered from here to here, right? I already have 10 there, but it is 25, everything. So football and tennis only. Now we now be 25 minus 10, and that's 15. I hope I'm not too fast. So now, these are some interesting interpretation of sets. And once you are able to interpret this and understand the difference between these statements, there is no question on the Venn diagram that you'll not be able to handle without stress. Okay? Now, the same as this consider that 20 like both football and tennis. This is for football. Sorry? 20 like both basketball now and tennis. This is for basketball and tennis. Basketball and tennis ranges from here. This is basketball, right? This is tennis. So the what is common to them ranges from here to here. But for basketball and tennis only now. Now with 20 minus, because everything is 20. 20 minus 10. So this is 10. Alright. Okay. Now we can get what will be left inside football now, which is known as football only. Alright. Everything inside football is 60. But when you look at that football, inside football you have 20, you have 10, you have 15. So subtract these 3 from 60. 20 plus 10, 30. 30 plus 15, 45. 60 minus 45, that's 15. This should be remaining 15. That's people that like only football without any other game. Just 15 of them. In case you are asked, you can just supply the answer. That is 15 like football only. Now for basketball only now, everything inside basketball should be 50 and you have 20, 10, 10. Take these 3 numbers away from 50. That's 20 plus 10, 30, 10 plus 10, 40. 50 minus 40, that's 10. So it means 10 students alone like basketball. I believe we are getting that, okay? And the same way for tennis, everything in tennis is 40. So we have these 3 numbers 10, 10, 15. So take this 3 number away from 40. So this is 10 plus 10, 20 plus 15, 35. 40 minus 35, that's 5. It means 5 students only like tennis. Now the question now says, how many students like none of the sports? So those that are not in this circle at all, but are still inside the survey, and this could be outside here, any part outside. I put it here, but here, it doesn't matter. So let's use letter X. Now, when we now add everything together inside this circle, and this letter X should give us 100. Okay, so let's add now. All this number, we add it. We have 7 of them now. Or 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Add it together. 15 plus 15, 30. Plus 20, 50. Plus 10, 60. Plus 10, 70. Plus 10, 80. Plus 5, 85. Then add it with X. And we say X plus 85 should be equals to 100. Then take away 85 on both sides. So we have X equals to 100 minus 85. So X equals to 15. So it means 15 students like none of the 3 sports. I believe you enjoyed this class. Stay tuned to this channel. And when next we go live, you'll be able to watch us again. And not only live class, we upload videos on interesting topics daily. So God bless you as you do. Blessed. See you next class and bye for now.